This video is going to show you how to apply some programming best practices to a very simple LED flasher program. We'll be using an Arduino Uno and two RGB LEDs connected through 330 ohm resistors to give us our blue and red lights. The code will start very basic and we'll improve it as we go, making use of two concepts that you need to learn early on: constants and functions. When we finish with the video, you'll have put together a program that simulates flashing police lights that you'll be able to customize yourself. So let's get started coding. The first thing we need to do is set our LED pins 2 and 3 as outputs. We do that with the pin mode function. Now that our pins are set up as outputs, we can write the code to turn them on and off to make them flash. This is done by alternating the LEDs, so turning one on and the other off with a short time delay in between. That takes care of the blue LED on pin 2. Now we want to do the same for the red LED on pin 3. So we'll set the blue LED low and the red LED high and add another delay. With that done, let's upload our sketch to our board and see the results. So our upload just completed and we can see our flashing lights. But they aren't exactly like flashing police lights, are they? Police lights have more of a strobing effect. I think we can improve this if we make each color flash twice. So let's go back to our code and do that. Pin 2 will be high and the blue LED will be on just after the first delay. We can add a few lines right after that to turn it off and back on again, giving us the strobing effect we want. Make sure to add that delay, otherwise you won't see them flash. Now do the exact same thing for the red LED on pin 3. With that done, let's upload our sketch and take a look. The sketch is uploading and okay, it's flashing twice. That's what we programmed it to do, but it isn't strobing fast enough because the delay between flashes is too long. That's an easy fix though. All we need to do is change the length of those delays. Let's go back to the program and correct it. Okay, here's the code again, but look, there's 6 places where we need to change the delay. We need to change all of these to make it blink faster. And if we still don't like the speed they're flashing, then we'll need to change them all again. If only there was something we could use to make it easier to change. There is, and it's called a constant. Constants let you set up a value in your program and use it anywhere you want, like in our delays. We're going to create one and set our delay times equal to it. That way, when we want to change it, we only have to change it in one place in the program and it changes everywhere. Declaring constants are usually done at the beginning of the program and in the same way as any other variable, except that it has the keyword const in front of it, like this. Since this video is about programming best practices, it's important to know that you should define constants with uppercase letters, like I did with flash speed. The reason is so that when you see it, it's immediately obvious that the value is a constant and it cannot be changed. Look at how high and low and output are written in the program. They're constants and they're written in uppercase. Another great thing about constants is that they don't use up any of your RAM space, which is already limited. That might not matter for a small project like this, but when your project starts to grow, it'll quickly become important. And it's a good idea to get into the habit of defining and using constants early on, especially if you're still learning. Let's use that constant in our program now and replace all of our hard-coded delay values with it. Just copy it, paste it everywhere you want to use it. Then let's upload our sketch and see how it looks with the constant values in place of the hard-coded values. Here's the program still with our hard-coded delays and it's uploading now. That looks alright, but I think we can still do better. Let's change the value of that constant and make it flash even faster. So real quick here, we're back in our code. All we have to do is find that constant, change its value in this one place and upload it back to our board. That's it. Just wait a second for the upload, and perfect, it looks good. It's flashing at a way more realistic speed. If we needed to tweak that value any further, it's just a matter of going to that one place in the program and changing it there. If it were a large project, you wouldn't even have to look through the code to find where it was flashing because it's declared right there at the beginning. Now, do you see another place where we can improve the program with the use of a constant? How about in the pin declaration for the LEDs? We're using pins 2 and 3, and there would be a lot of places we would have to change this if we needed to change pins. And changing pins is a real possibility. It happens all the time. We're using pin 3 for the red LED, which is a PWM pin. If the project had motors and needed all the PWM pins, we'd need to change it. If we use a constant in its place, it'd be no trouble at all. Let's do that now. We'll go to the top of the program and declare our two LED pin constants in the same way we declared the flash speed. We'll call the first one blue LED, which is on pin 2, and red LED, which is on pin 3. Both are declared using uppercase letters like they should be. Then we'll copy the name of the constant and we'll paste it into the program everywhere we want to use it. Do the same for the red LED. And don't forget to change the pins in the setup, which I just about missed doing here. And we're finished. For the sake of this example, let's pretend that we did need to change pins. Let's change the red LED's pin from pin 3 to pin 4 and upload our sketch and see what happens. And now we wait for the upload to complete, and there it goes. Our new program starts and only the blue LED is flashing, which is what we expect because we told the program to use pin 4. So I'll grab the jumper wire and I'll just move it over one space, and there we go. Our red LED is working on pin 4. Making good use of constants in this way will make working with your program much easier, especially if you come back to it after a few months or if you share the code with someone else. Our program is finished and it's working exactly the way we want it to, but if we look at it, it's really just a bunch of lines of code that doesn't make a lot of sense at first glance. If someone were to walk into the room and look at it, would they be able to understand what it did? Would they have to decipher it? Wouldn't it be nice if you could read your program like a book, like wrapping your code into a statement called flash blue LED and flash red LED? Well, you're in luck. You can do exactly that with something called functions. Functions are amazingly powerful, and if you're new to programming, you need to start using them right away. The best way to understand functions is with an example. So what we're going to do is delete all of our code and replace it with function calls. Your functions should describe exactly what you're doing, and what we're going to do is flash the red and blue LEDs. So that is what we're going to call our functions. Since we want to flash each LED twice, we're going to call each function twice. These function calls end in an open and closing bracket and follows the same syntax as our loop function and our setup function. Loop and setup are just functions that were already created for you, whether you knew they were functions or not. Let's go down the screen below our loop function and start writing the code for our own functions called flash red LED and flash blue LED. We'll be following the same syntax as the loop and setup functions, which means prefixing them with the keyword void and using open and closing round brackets after the function name, as well as open and closing curly brackets, which will contain our code. Let's go inside the curly brackets for the flash red LED function. Like I said, these curly brackets will contain our code just as the setup and loop functions did. Here's where we're going to write the physical code that will flash the LED. We're going to write the same code we wrote earlier. A digital write to turn the LED on, a delay to keep it on for the amount of time specified in flash speed, a digital write to turn the LED off, and finally another delay. Our code is already more readable. Everything to do with flashing the red LED is right here in this function. And anytime we want our program to flash that red LED, we just call that function like we did up here. We need to write the code for the blue LED. So we're going to copy the code from the flash red LED function, paste it into the flash blue LED function. And then we need to change the red LED constant to blue. Look how clean and readable our program is. When you look at the main loop, it's clear what the program does without having to read any lines of raw code. And when you do look at the raw code, it's nicely organized into functions where it's easy to read. Here's where working with functions gets really nice. Let's say you want each of the LEDs to flash 4 times. It's so simple to jump up to our main loop and add a couple more function calls. Even better, wrap those function calls in a loop and tell it to repeat X number of times. There is so much you can do to make your program more readable and maintainable with constants and functions, which is why I covered those two topics in my first video. If you're new to programming or just getting started, now is the best time to begin applying those programming best practices to your work. You'll appreciate it down the road.